Okay, we're here with Jordan, and we're going to review solving equations and inequalities. Some of this will be reviewed for you. Ready to go?
Yep.
Okay, so let's first talk about equations. And remember, with an equation, what we want to get to is x equals something. We want x by itself equal to something, right?
Right.
Okay, so let's start with this pretty complicated equation here. There's a lot going on. What I like to do first is to make sure I've taken care of any sort of distributive property here. So with this equation, where's the distributive property? On the left side or the right side?
The right side.
Right side, okay. So let's go ahead and apply the distributive property to simplify that. So the left-hand side is still going to be 5x plus 4. What's the right-hand side going to be, the first part?
2x.
2x, and then minus, and then 2 times 5.5. Any ideas?
I'm not sure.
Yeah, what would 2 times 5 be?
10.
10. And 2 times a half?
1.
1. So 10 and 1 is?
11.
11. So we'll have 5x plus 4 equals 2x minus 11. Okay? All right. So now, what I like to do, what do you like to do next when you're solving an equation like this? What would you do?
I would simplify the part on the left.
On the part on the left, and how would you do that?
I would subtract 4 from both sides.
You could subtract 4 from both sides and start getting rid of the stuff that's bugging you over here, right?
Right.
That's a good idea. Usually, and this is one of the things in this kind of math. There's probably 5 different ways that you could go here. So I went a slightly different way. Tell me what you think of this. I'm going to try to get the x's all on one side first before I start moving the numbers around. So I'm going to go ahead and subtract 2x from both sides. Does that make sense to you, why I would do that?
Yeah.
Okay. So now after I do that, what am I going to have on the left side?
3x.
3x plus 4. And then on the right side, that 2x goes away, and I just have minus 11, right?
Right.
Yeah, be careful here that you don't just put 11, because it is a minus 11. Always want to be careful there. Okay, now, there's 2 things that are bugging us here on the left-hand side so that we can get to x by itself. What are they?
The 3 and the 4.
Yep, the 3 is multiplying in the 4, and this is where your instinct is to subtract 4 probably again, right?
Right.
Yeah, same with me. You could divide by 3 right now, but then you would get rid of that 3, but then you would have 4 thirds and negative 11 thirds, and I don't know about you, but I don't want to be messing with a bunch of thirds as I add and subtract and stuff. I like to keep my numbers as simple as possible. So I think that the next best thing is the most convenient thing is to go ahead and subtract 4 from both sides. And this is the step. We're going to choose the next step in the order that's most convenient, in the way that you like to do it the best. And so me too, I like to subtract 4. So let's go ahead and do that. What are we going to have on the left-hand side after that?
3x.
And how about on the right-hand side?
15? Negative 15.
Negative 15. Very good. You did some mental math with negative numbers. That's good. Okay, now what's still bugging us?
The 3.
That 3. And what's it doing to the x?
Multiplying.
So what are we going to do?
Divide.
Divide. So we'll go ahead and do this over here on this side. And so we have 3x over 3. So that's just going to leave what on the left side?
X.
X. So we get our x by itself. Excellent. And then what's that going to be on the right-hand side? A negative 15 divided by a positive 3.
Negative 5.
Negative 5. Very good. And so that's our answer there. So again, the steps we went through is to go ahead and take care of any distributive property to simplify. Then I like to get all the variables on one side. Then do the steps that are in the most convenient order for you. And here we did subtraction first, and then we did our division. And it's always a good idea. I know students don't like to take the time to do this sometimes, but it's always a good idea to check your answer. So let's take this negative 5 and just really quickly, we're going to put it back in our original equation right up here. So I'm going to take any place there's an x, I'm going to go ahead and put negative 5 instead. So I have 5 times negative 5 plus 4 equals 2 times negative 5 minus 5.5. Do you see how that's the same exact equation as up here, but I've just put in negative 5 for x?
Yeah.
Okay, good. So let's go ahead and simplify this side. What's 5 times negative 5 over here?
Negative 25.
Negative 25, okay. And then we'll just keep going along here. Negative 25 plus 4. And then what's negative 5 plus negative 5.5? Does it make sense that it's negative 10.5?
Yep.
Okay. Now let's go ahead and add up the left-hand side. What's negative 5 plus 24?
Negative 21.
Very good. And what's 2 times negative 10.5?
Negative 21.
Negative 21. So, hallelujah. We have negative 21 equals negative 21. Is that true?
Yep.
Yep. So that means that our answer is correct. We just did a quick check of our answer. Isn't that great?
Mm-hmm.
Okay, now let's move over to inequalities. It's going to be very similar. One difference, though, is you're not trying to get x equals, because in inequalities we don't have an equal sign. You need to get x by itself, and then there's going to be some sort of inequality like greater than or less than or equal to or something like that. Okay, and then there is one other difference, and I think you probably remember it. Let's see if we can move through a problem that looks like this. So we have negative x over 2 plus 3 is greater than or equal to 9. So just as we did over here, we would do any distributive property first. Do you see any distributive property here?
No.
Okay, and then we would get all the variables on one side. Are all the variables already on one side? Oh my gosh, we're halfway to the solution. Okay, so then we do the steps in the order that's most convenient. So let's go ahead and write that that's what we're doing. And then, so what would you do next here?
I would subtract 3 from both
Okay,
sides.
good. I think that would be a lot easier too. Now, in this case, multiplying by 2, or better yet, negative 2, would make it still pretty convenient. We wouldn't be dealing with any fractions, but I agree with you. I like to subtract 3 from both sides first. No right answer to that, though. Some people would multiply by 2. So when we subtract 3 from both sides, what's on the left-hand side? What's left over?
Negative x over 2.
And how about on the right-hand side?
6.
Okay, good. So negative x over 2 is greater than or equal to 6. Now, what would you do next? And this is a tiny bit tricky. What would you do?
I would multiply by negative 2.
Multiply by negative 2. And that's excellent, Jordan, because when we have negative x over 2, it's really x divided by negative 2. Same thing, right?
Right.
So that negative 2 is dividing into the x. So we want to do the opposite, which is to multiply. Forgetting that negative would then leave us with negative x. So it's really great that you decided to multiply by negative 2. And we have a big note here that we want to pay attention to, which is whenever we multiply by a negative number, or when we divide by a negative number, and we're working with inequalities, you have to switch the direction of the inequality. So I'm calling that out here in bold letters. So here we have negative 2 times x over negative 2. What's going to be left there?
X.
X, good. And how about on that right-hand side? What's 6 times negative 2?
Negative 12.
Negative 12. Okay, so there's our answer right there. X is less than or equal to negative 12. But we're probably not done until we check our answer. So with inequalities, there's not just one answer. So you have to pick an answer that would make the inequality true. And whenever it's a less than or equal to, I like to check the equal to part of that. Okay, so let's go ahead and check x is equal to negative 12. So I'm going to take negative 12 and I'm going to put it right into this equation, or inequality, up here. So it's going to be negative 12 over 2, a negative of that, plus 3 is greater than or equal to 9. See how that's the same as this up here?
Yeah.
Okay, good. So now what's negative 12 over 2?
I'm not sure.
So what's 12 divided by 2?
6.
6. So negative 12 divided by 2 would be?
Negative 6.
Negative 6. So here we're going to have a negative, which was this first negative out here, of a negative 6, which is the negative 12 divided by 2. You following so far?
Yep.
Okay. Then plus 3 is greater than or equal to 9. So then what's a negative 6?
Positive 6.
Positive 6. So here we now simplify this to 6 plus 3 is greater than or equal to 9. Is that true?
Yep.
Yep, because 6 plus 3 is 9. That's equal to 9, so it's true. Okay, so negative 12 worked. Now, we're saying that x should be less than or equal to negative 12. So let's choose one other number that's, instead of equal to negative 12, let's make it less than. What's a good number that's less than negative 12?
Negative 14.
Negative 14 is perfect. You could do negative 13, but then because it's not even, it's going to be hard to divide by 2, and that makes your life difficult. So make your life easy with math for sure. So let's go ahead and try negative 14. That's an excellent choice. So negative 14 divided by 2 is what?
7.
And is it positive or negative?
Negative.
Negative 7. So we have a negative 7 plus 3 is greater than or equal to 9. So what's a negative 7?
Positive 7.
Positive 7. So now we have 7 plus 3 is greater than or equal to 9. Is that true?
Yep.
Yep, because 7 plus 3 is 10, and that's greater than 9. So that's, you get that true too. So just remember our steps. If you need to do any distributive property, do that. Get all the variables on one side. Then follow the order that's most convenient for you. Make your life easy. And then go ahead and always check your answer. Make sense?
Yep.
Great job.